sound like one chapter text. So do what? So in order to get that test graded on time, that test will be multiple choice. Okay, so your test next Tuesday on chapter 6 is multiple choice, so I can get those grades in. So today we start the last section of chapter 6. We'll spend 3 days on it and review this next Tuesday. If you know you're going to be out of town, please take it early on Monday. Technically, in my calendar, I had it scheduled for Monday, but I just bumped it to Tuesday because Monday tests are done. And because we have an early out Wednesday. When you're graphing exponential equations, like this one, you're supposed to make a table. This is an exponential equation. It is not a log equation. So you make a table for x. You plug in for x. So when I look at that, the transformations I see is up 4. So it's the x and it's moved up 4 units. I'm gonna look around and see if there's graphs. So mostly I don't like to work with mixed numbers, but here it makes sense. 3 to the negative 2 is 1/9 plus 4. I'm just going to go ahead and look at that as 4 and 1/9, making it quick. And then 3 to the negative 1 is 1/3. So that's just 4 and 1/3 for my y value. And we know 3 to the 0 is 1, so that's nice. Finally, we have an integer of 5. And then we got a 7. We got a 13. So here's our ordered pairs. So you should be recognizing this graph looks a lot like your credit card graphs. It's the same curve. It starts moving kind of slowly, it's kind of flat, and then all of a sudden it starts to move up quickly. This is an exponential graph, and we did this a couple weeks ago, exponential graph. Kayla C, could you tell me domain and range? Wait, do you know the name of this dashed line I'm drawing? How about that? You know the name of that? Okay, and then you think about domain and range. Does anybody know the name of this dashed line I decided to put here? Maybe you know it, but you're afraid to say it wrong. That's my asymptote. Because this is shifted up 4 and kind of the concept of exponents, remember, negative exponents don't make negative numbers, they make fractions. So even if I went x negative 3, that's just 1 over 27, and negative 4 would make 1 over 81. Like, I'm never creating a negative number here. So for that reason, this red line will never go below 4. It'll always be 4 plus something else, positive. So that's a floor, it's an asymptote. It'll never go below that floor. All right, Kayla, what do you got? Yes, your domain is all real numbers. Yeah, 4 to infinity. Good job. So our domain, x could be anything, negative to positive infinity. But our ranges are limited by that asymptote and this concept that it'll never go lower than 4. So our range is 4 to infinity. If there was no plus 4 here, it would be 0 to infinity. And then if that was an 8, it would be 8 to infinity. Okay. All right, let's go on to number 3, finding inverse. Swap x and y. That's from chapter 5. I wasn't sure if you guys would even know. Well, to find inverse, swap x and y. I'll read it. And then what do you do after you switch x and y? You get y alone. Solve for y. So I would, instead of f of x, I would write it as a y value. So you guys go ahead and try. Try to get y alone. Switch x and y and try to get y alone. Tricky, I've never shown it to you before. Your first time trying it, but you might as well look at it before I just tell you. Did you do it really? Did you switch x to y? Did you rewrite it yet?
I did switch it.
Okay, did you do one move?
I did what?
Did you do any moves after you switched? There's one basic move that you can do. Maybe it wasn't, yeah. Subtract 4. Yeah, you can go ahead and subtract 4. And that's where you should be stuck. That's where it's something I've never shown you how to do before. So yeah, our goal is to get this y by itself over here. So I guess I could move the 4. No, I can't. If this was multiple, if it was 3 times y, I would be dividing. But that is not multiplication, that's an exponent. So it's like maybe I want to take the y root of both sides, but what's the y root? I don't get that. So y is in an exponent spot. What solves for exponents? Logarithm solve for exponents. So to get y alone, we'll have to do a logarithm. Logarithm solve for exponents. Well, like this log is an operation like a root, you know, it's just that instead of a symbol, we use the word log. So, um, are you able to convert this to log form right now? I mean, step 1 of writing log form was just to write the word log out. And then, what would be the base of our logarithm? 3 would be base 3. The base of the exponent is 3, so this is log base 3. The next spot is always the result of the exponential equation. So right here, I'm going to put in that x minus 4, like that whole group goes in here. So I use parentheses, I group it. And of course, logarithms equal exponents. So our y is 1. So right here, we've proven that the inverse of an exponential equation is a log equation. You guys remember function notation would be a little -1 there. All right, that's the official inverse. All right, so next we have to graph the inverse. Our goal would be to put the graph on this same coordinate plane. So Friday when I wasn't here, I said, read that one page about graphing logarithms. We graphed logarithms Wednesday. And then Thursday we did properties, and then Friday I wasn't here, so you were supposed to read about graphing transformations. The transformation here, because there's a -4, is we're going to graph log base 3 of x, and then we're going to go right 4. That -4 just means we'll do. And we graphed log base 3 of x on Wednesday. We've already created that graph. So we're going to make that same one and move it right forward. So to graph a logarithm, what did I say? You make your table with the y values. Or you put the numbers in the y value part. So here we are, x and y. And this time for a log, I plug in the y side. I plug in the y side to graph the logarithm. That was discussed last Wednesday. Don't know if you were here or not. That's what we did. So guys, I'm going to focus just to make this transformation easy. I'm actually going to focus on just this graph, and then I'm just going to move it right forward. So I think I said to graph a log, we make the table for y. And I said consider the exponential form. So that would be 3 to the y equals x. So to come up with our x's, we'll do 3 to the -2 equals x. 3 to the -1 equals x. 3 to the 0 is x. 3 to the first is x. And 3 squared is x. That's how you find your x's. Logarithms, you do it kind of backwards. That's one strategy. Get your x's, move them right forward, plot on the your graph. Um, right here. You talking about this?
Shrink the y alone.
Yeah.
You
The only way to get a y alone, or to get an exponent alone, is to use a logarithm. Logarithms do exponents alone. So now I'm graphing that logarithm. So this would mean that 1/9 is our x value, and that 1/3 is our x value. 1 is x, 3 is x, and 9 is x. We did that. But our graph has this -4, which means we're gonna go right 4. So we're actually gonna add 4 to these. So the real x's are 4 and 1/9, 4 and 1/3, 5, 7, and 13. Okay, and we've again proven inverse because our inverse table is exactly x and y switched as our original table, and that's the definition of inverse is that x and y are reversed. We did the math and got there. So I want you to put that picture on the same graph. So you can see the logarithm and its inverse all in the same place. You should see inverse reflects diagonally. So you should see a diagonal reflection between your ordered pairs. Yes, I'll do it. 4 and 1/9 and -2. 4 and 1/3 and -1. 5 and 0. 7 and 1. And 13 and 2. Wish that was a little straighter. So this is x equals 4. It's a vertical asymptote. So an exponential graph will have a floor or a ceiling that it'll never go through. A log graph has a vertical wall that it'll never go past. So the domain and range for log graphs, this time x's will always be higher than 4, and it's a range that is all real numbers. Or why is this? This will go up forever. You just can't tell. So this really should be, so the whole reason that we learn inverse, well, there's a lot of reasons why inverse, but the inverse in chapter 5 really was important for understanding the relationship between exponents and logarithms here. Okay, so on your test next Tuesday, you'll be asked questions about log graphs. Their tables, their transformations, and you'll be asked about inverses. Switching x and y and get y. All right, I'm going to show you the answer to the graph I assigned Friday. It was like number 25. And I'm going to walk around and give you credit for doing the even problems. So get out your assignment from Friday. And you can, as I'm walking around, you can think more about these 4 questions, 3 I guess, and how they're related. I bet that the stretch was difficult on this. Hopefully you moved it down. So multiplying it by 3 means just multiplying all your y values by 3. That's good for your brain. It's good for your brain to be bored. Wait, for real? It's weird. No, it's good for your brains to be bored, right?
No.
No.
Bitch, no. No, that's not real.
I've said it in this time.
You said it once.
No.
Wait. Yeah, you said it once.
Like that's fake.
Wait, what's the science behind that?
Then it starts working and imagining things and reading or observing. But if you just pick up your phone and you scroll through stories, your brain's not working at all. It's getting fed entertainment. Your brain is resting. Your emotions are resting. And they're not in the moment. So the more you scroll through your phone throughout the day, the less you're using your brain as it should be with all of its emotions and abilities to observe and learn new things. So stop scrolling because you're wasting your own brain power. You're not growing. No, it feels weird.
Girl, the other side.
So I can see evens and odds, and I can see a graph on number 25. Evens and odds, and a graph on number 25. Oh, and then I give you a 1 on that last slide. Instead of a 4. How many questions was it down? Was it on 7 or 3?
Check. Literally half. Oh, it's down 7.
Like before, when we didn't have phones, like
Oh my gosh.
we would flip through our textbooks.
Why are you lying? Why are you lying?
No, when I was a high school student, and we didn't have the internet and cell phones, we sat there and we would look in our textbook when we were bored. There's pictures.
6:09. I'm gonna start my homework. I need to get my homework right. I've been doing homework.
Maybe next
Breakfast meeting. What's called? Christmas wrap. Christmas wrap. Girl. Actually, give me. Homework grind. After my math homework. Alright, got it. Too easy, it's hard to do. It's kind of hard. Consider turkey turkey. Oh, why you spoiling? Really hide that. Number 11. Why? Your first game? I only have like 5. Oh, perfect. That's why I'm going. I'll go tomorrow. I'll go tomorrow.
Okay, yeah. Okay. Which one?
Honestly, I shouldn't do it.
And then for the extra credit on like the credit card APM, what is that? Does that go to assignments or is that? Where are you going? You're going together? That's right.
No, that's so loud.
Let me try my other.
Okay, so I have to do 3 more problems with you. These 3 problems must be done today. This is chapter 6.6, solving exponential equations. We'll spend 3 days in this section. These problems, there's 3 levels of difficulty. So I'm going to do one of each type with you. The first level of difficulty is basic. That's when you're given a problem and it has the same base on both sides. That's setting up for you kind of a basic problem. The second type, there's not the same base on both sides, but you can create it. Like you can work the numbers and make the same base on both sides. And then the third type, it's impossible to create the same base on both sides, so you have to use a logarithm. Okay, could you put your phone away and write down the notes? That's always so fun. Focus on the math problem, please. Who's sitting here? Oh, he's here. Okay. So we're only missing Landon and Melina. You see it? You see a bunch of assignments there? What's the due?
Just tomorrow.
I think it'll let you do it later.
Well,
You guys, the due date on the chapter 5 remediation Khan Academy is tomorrow. I put that cutoff there just knowing that there's a test next week. I didn't want them to get. You know, if anybody wants an extension on that Khan Academy, let me know.
I did all things except like one.
Okay, so you just done it and you're waiting to update your
Yes.
Yeah. Khan Academy only works for grades less than 60. Please keep that in mind.
Do we have to get $100
Quite a few.
credit for it?
No, I use credit for 3 out of 4.
Okay.
Yeah.
Because most of them are 4 questions, 3 out of 4.
I want to check it. What if you did like all of them, but like one of them?
Probably fine. Probably just fine. And I kind of gauge it. I try to be flexible when I gauge it. If someone got a 58 and their grade's only moving to a 60, you don't need to do all of that remediation. So I try to be kind of fair about it.
Yeah. So if Riley were to do every single, just using a friend as an example.
Yeah.
If Riley here did every single Khan Academy thing, how much would said grade boost?
The text grade moves to a 60.
That's it? Sorry.
Oh my god.
Grateful. So, but what it means is if you do every assignment, if you do every assignment, and you can never earn lower than a 60 on a quiz or a test, it's impossible to fail. So there's no, like, everybody can earn high school credit for this class.
Will fail as in like, it's impossible to fail as in like they'll get a D.
Actually, if you do all of it, if you always get higher than a 60 on your quiz or test, and you do 100% of everything else, all work quizzes, everything, you'll get a C.
What type of C? Like F79 or like F7?
Oh my god.
It ain't that
Not that serious.
A 70.
So I got like I got a 56 on this test.
Just like hypothetically.
How many Khan Academies do you
Yeah.
You said 56.
Yeah.
You should do like 4.
How long was it?
40 minutes.
The first quiz, like the first grade in our thing, will it count for that?
Yeah, you can do it for that.
Oh my gosh.
Yeah.
We remind us that are gonna be due like tomorrow. Or
You can do it. You can do it.
Oh, okay.
I just put that due date so that it doesn't, because everybody will, right before the end of the quarter, you'll try to, because you're going to want to remediate the test next week. So I don't want you remediating both tests at the same time. So the purpose was to finish chapter 5 before we start chapter 6. Now that means that if you get a 70 on third quarter because you did all the Khan Academy and all the work, and you get a 70 on fourth quarter because you did all the Khan Academy and all the work, but you didn't understand any of it, you will fail the exam and you will have a D for the semester. Okay. So you have to learn something to achieve a C for the semester. But if you just do everything, you won't have to do summer school.
If through summer school?
There's summer school?
Yeah.
Can you just
Oh my gosh.
I mean,
I'm just joking.
yeah, you
Summer
have to get
school.
4 high school credits.
I'm scared.
Scared of us.
But some of you guys got a high school credit in middle school.
Real.
Let's move on. And I have 3
Yeah, but
problems.
get that.
How much time do I have to get 3 problems in?
Oh my god. That scared me. Cause. Literally can't. Oh.
Does anybody see my time?
This ball when it's right next to your computer.
Who's like searching? I didn't find it. She's still searching.
Oh my goodness. Wait, so what 3 questions? Oh,
This is them, guys.
never mind.
So far, I love it.
It's okay. Problems they increase difficulty. They increase in difficulty. So side by side you can see same base, 7 and 7, same base, 7 and 7. You can see in number 2 they don't have the same base, but 8 and 2 they belong to the same number family. So we'll be able to create the same base. In number 3, they don't have the same base, and 7 and 15 have nothing in common. So for that, we're going to need to use a logarithm, and we'll be relying on our calculators. Okay? So basic, medium, most difficult. So if you're given a problem with the same base, property of equality says we can just drop that base and equate exponents. I really like that word, equate exponent. So I'm gonna drop the base. And now this is just a algebra 1 equation. Just get x alone.
Oh my god. That was terrible.
Is that only if they're like the same number?
Oh,
Like if
yeah.
they're-
I literally just said that. Oh my god. Get out of here right now. Literally my worst enemies.
All right, so that problem, that's the most basic. Number 2, I can't just cross out 2 and 8. They're not the same. That's not the property of equality. So I have to create the same base. What I'll do is I'll rewrite 8 as a smaller number. Like 2 to the 3rd.
No, because it doesn't have the same base.
Yeah.
Literally.
If these numbers are the same, you can just drop them. Because if 7 to this power equals 7 to this power, well, then those exponents have to be the same. Reasonable. So now we'll use our property of equality, our power property of exponents, and distribute the 3 through. I made a mistake here last period, and they were roasting.
That's so mean. Oh
They
my
were
god.
not impressed. So now I've made the same base, I can drop it and equate exponents.
Oh my god. I like this part.
Yeah, I like to drop the base as well.
Oh my god.
And then I was feeling nervous and I messed up here as well.
No. I played
I wrote a 7 instead of a -1. Oh no. And they thought I was
She knew to
Oh,
go.
okay. She's no good with numbers. It was a rough time.
We're doing better this period.
Oh my gosh,
Oh,
literally had
wait.
like 2 seconds.
Okay, so yeah, so here, this is the really important one. So we're gonna have to, because they can't make the same base, you write the log on both sides. Alright, so I wrote log 7 on both sides, and that's okay with my properties of equality. Now this is something special here. Any base, you think 7 to what power is 7? And it's 1. So I'm able to cross that out and make it a 1.
1.
Alright, this is the change of base formula I told you guys about last Thursday, but we haven't used it yet.
Oh.
So from here, it's calculated right. So I'm going to divide 9.
There you go. Thank you.
So now I'll go to a calculator. I'll use my fraction button. I do log 15 divided by log 7, enter. Divide by 9, enter. And that's my answer. I think it's 0.15.
I can't write right now.
These 3 examples, very similar ones, are in your book. So please use your book. Hopefully you worked out the whole section.
I literally did that.
It's 0.15.
Me too. That's my favorite.
The majority of your assignment is problem 1 and 2.
Yay!
The same base thing. I think there's only one where we're required to use our calculator.
Actually,